All right, well, this is going to be section 8.5. All right. All right, we're going to be solving these equations. The first example I have on the board here. Anybody know what this is called? When you have one ratio equaling another ratio? Read. Proportion. This is a proportion. And the way we solve proportions is by cross multiplying. Okay? And something about a proportion. If you have one fraction equaling another fraction, they look different. It means that the cross products are equal. So I can cross multiply and set those two products equal to one another. So that 3 times 1 is equal to x times x minus 2, or x squared minus 2x. Okay? And we solve that by setting that equation equal to 0. And we factor if possible. If not, we have to use quadratic formula. Right? So 0 equals, and that one's easily factorable. It's x minus 3, x plus 1. And so my solutions are 3 and negative 1. And you can check that easy enough. Do you have a question, Alec? No? Okay. All right, so the solution is 3 and negative 1. If I put in 3 for x, on the left-hand side, 3 over 3, that equals 1. If I put 3 in for x on the right-hand side, in your denominator, 3 minus 2 is 1, 1 over 1 is 1, so 1 equals 1. So it does check, and it's real easy to check. Okay? So you'll have some problems like that where it's real simple. We just cross-multiply. All right, now the next one. Well, this is a little bit different. And there's a couple of ways to go about it. Can you think of any ways?
You just subtract the 2 first and then cross multiply.
That's one way. I could combine these first two terms on the left and then cross multiply. Sure, one way to do it. Is there another way?
Can you solve the proportion or one of them and make them go together?
That I can't do. Okay. If I had a problem over here, like maybe 2 over 3 plus 1/2 is equal to x over 12. Didn't we have a problem where we could have cleared fractions and multiplied this whole thing by? What would you multiply that whole thing by to clear fractions?
12.
By 12, sure. If I multiplied this by 12, 3 goes into 12, 4. 4 times 2, I would have 8, 2/3 times 12. And 2 goes into 12, that would cancel. You get a 6. 1 times 6 is 6. And the 12s would cancel. Which will leave me with x. And it's a little bit simpler problem to deal with. Well, that's what we're going to do here. I'm going to take this whole entire equation and I'm going to multiply by the common denominator. It makes it a lot easier to deal with. Well, here in the middle one, it is x minus 2, x plus 2. If you agree that the x minus 2, x plus 2 will be your common denominator?
Yes.
Okay. So I'm going to multiply by x minus 2, x plus 2. And that method is called clearing fractions. Multiply by the first term, by this first term here. The x plus 2's will cancel. So I'm left with x times x minus 2. Minus. In the second term, the x minus 2 and x plus 2 will both cancel. The x minus 2 will cancel with this x minus 2. The x plus 2's will cancel. And I'm just left with 8 equals. And in the last term, the x minus 2's will cancel. And I've got 2 times x plus 2. And that's a much easier problem to solve. So let's go ahead and simplify that. X squared minus 2x minus 8 equals 2x plus 4. Setting the equation equal to 0, I have x squared, subtract 2x from each side, and subtract 4 from each side. And that's a fairly simple equation of factor. If it doesn't factor, we need to use quadratic formula. But this does factor. It is x minus 6, x plus 2. And so my solution here is 6 and negative 2. All right? Anybody see any issues? Andrew, do you see any issues up there? There are no mistakes. Yes, Luke?
For the denominator on the first one, the x plus 2 and x minus 2, we need that by 2.
So what are you saying then? What's your conclusion then? You're right. What is your conclusion?
I don't know. I just thought of it.
Okay. Well, and he's correct. Negative 2 I can't use, because if you look at the original problem, if I put in negative 2 for x, I'm going to get 0 in denominator. So even though it's a solution, that solution doesn't work. Do you remember what we call that? No, this is, well, yeah, but we're not about graphing. Yeah. Extraneous, very good. Extraneous solution. All right, it's a solution that we get, but the solution that we can't use. All right, and so it's called an extraneous solution. So the only one that works here is 6. Okay? So it's real important, once you get your answers, to check and make sure it's not a restriction. Any questions? All right. You want to see another problem? You want to see another example? All right. I have one up here in blue. Donna, can you tell me what the common denominator is?
Would it be the t plus 1 times this one?
Yeah, it'd be t times t minus 1. It's just all three of those denominators. It's all factored. All right, so let's distribute that common denominator. In the first one, the t minus 1 will cancel with this t minus 1. And I've got t plus 1 times t times t plus 1. You see it? Minus, I'm going to have the 3 there no matter what. Well, here now the t's will cancel, and I've got t minus 1, t plus 1. And it equals. On the right side of the equal sign, the t plus 1s will cancel. And I have t times t minus 1. And it looks like it's confusing, but once you multiply everything out, combine like terms, let's do that. So I have t times. If I square this, I'm going to get t squared plus 2t plus 1 minus 3 times, and if I use FOIL there, I'm going to get t squared minus 1 equals, I'll distribute the t squared here, and I get t cubed minus t squared. Distribute the t, and I get t cubed plus 2t squared plus t minus 3t squared plus 3 equals t cubed minus t squared. So it's really not that bad. It takes a little time. If I subtract t cubed from each side, t cubes will go, so we don't even have to worry about that. And I have t squared minus t squared is negative 1t squared plus t plus 3 equals negative t squared. And if I add t squared to both sides, they cancel. So I'm left with t plus 3 equals what? 0. T equals negative 3. Real quickly, I'm just going to check back here in the original problem to make sure that it's not a restriction, and it's not. I can use negative 3, and that's my answer. Okay? All right. Let's take a look at, and that's how we solve equations with rational polynomials. Let's take a look at the example in green. Cross multiply. It's the same type of thing. I put the 1 underneath the 3 just to show you that we can cross multiply. And because we have inequalities, we're going to use a number line. Cody, can you tell me what value, looking at that problem, I cannot use? Negative 2. So here at negative 2, I'm going to put an open circle. Because no matter what, I cannot use that. Now let's solve it. And we solve it by cross multiplying. X minus 1 times 1 is x minus 1. Now do I flip that sign? How do you know? Well, the answer is you don't know. Because you don't know what x is. So you don't know if you should flip the sign. The book suggests that you're going to show where it is greater than 3x plus 6, and then less than. All right, I've got an easier way. We're going to set this equal to one another. Forgetting the sign right now. And cross multiply, I'm going to get 3x plus 6. And let's solve it. Subtract x from each side, subtract 6 from each side, and divide by 2. Okay. Negative 7/2. That's out here, isn't it? Negative 3.5. Negative 7/2. Is it going to be an open circle or a closed circle? Open. Why is it going to be open? In the original problem. That's what we just solved. All right. Now, how do we know? Is this a conjunction? Is it a disjunction? We test the intervals. It is the easiest way. Go to the original problem, put in 0 for x. 0 minus 1 over 0 plus 2. Is that less than 3? Yes. It worked. If one number to the right of negative 2 works, they all work. Okay? Let's try a number between negative 2 and negative 7/2. Let's try negative 3. Negative 3 minus 1 is negative 4. Negative 3 plus 2 is negative 1. Is that less than 3? No. And if we try to value maybe negative 4. Negative 4 minus 1 is negative 5. Negative 4 plus 2 is negative 2, which is a positive 2.5. Is that less than 3? Yes. So all values out in this interval work. These do not work. And this does. Remember what I said about these intervals? A lot of times, not always, but most times, these intervals alternate. If one works, the next one won't. and the next one will. So they sort of alternate. And so this becomes an OR statement. X is less than negative 7/2, or X is greater than negative 2. Okay? All right, let's try a couple more. Number line. Here's my 0. What can I not use? I cannot use 3. So I'm going to put an open circle. What else can I not use? Negative 3. I'm going to put an open circle. No matter what, those are going to be open circles. Now let's solve it. Cross multiply. All right, x minus 2 times x plus 3. You know, in this problem, algebraically, it becomes very difficult to do. And sometimes the algebra is going to get beyond us. The book suggests that you use your calculator to graph the left side and the right side, or set it equal to 0 and graph it. I really find that confusing, but if you'd like to read the book and use your calculator and your graphing to graph those, go ahead. I happen to think this is easier and it's more efficient. So I'm going to set this equal, and then we'll cross multiply the other two. I'm going to have 2 times x minus 3. And we know that we can't use 3 and negative 3 because those are our restrictions in the first original equation. All right, so I'm going to have x squared plus x minus 6 equals 2x squared minus 6x. Set the equation equal to 0. Subtract x squared from each side. Subtract x from each side. Add 6 to both sides. And factor. X minus 6, x minus 1. So I've got 1, and I've got 6. Open circles are closed. In this case, it's open because the original problem is just greater than. Now I have a lot of intervals to check. And let's check 0. Okay. So if we check 0, and I'll save you a little bit of work here. If you put in 0 for x, it's going to work. If this number works, they all work. Right? So this will work in here. This interval will not work. A lot of times, most times, they alternate. This will not work. Not always. These intervals will work, and these will not. So we write our solution. X is between negative 3 and 1, or x is between 3 and 6. So it's kind of a combination of conjunctions and disjunctions. A little bit tricky. Okay? One more. Tomorrow, you know that you guys are not coming in until, or you're not starting at first hour until 7:54, correct? For the first few minutes, you have a chance to see 3 classes that you might be interested in. And I think while I'm going over this problem, I'm going to pass this around. This is a list of all the classes and the room numbers. So for instance, if you're interested in taking marketing, it's going to be with Mr. Oak in room 101, 102. So if you want to write down the numbers on the plan where you're going to go tomorrow, I'll pass this around. Yeah.
So where do we go, right?
I know I'm recording. You go to your first one of those sections. Okay? All right. The common denominator here. Well, if I factor a minus 1, a plus 1 here, that becomes my common denominator. So I'm going to multiply by the common denominator of a minus 1, a plus 1. All right. Drawing my number line. And I drew a big number line. I don't know, what my answers are going to be, but I do know that I cannot use 1 or negative 1 no matter what. Here's 1, here's negative 1, and I can't use those values no matter what. They have to be open circles. We have no choice. All right, let's solve it. In the first expression, the a minus 1's will cancel, and I'm left with a times a plus 1 minus. In the second one, the a plus 1's will cancel, and I have 2 times a minus 1. Don't worry about the inequality sign. We're going to make it equal. And here, the a minus 1 and the a plus 1 will both cancel, and I'll simply be left with 5. And isn't that an easier problem to deal with? Okay. Again, the book suggests subtracting this from both sides, using a graph. All right, so we have a squared plus a minus 2a plus 2 equals 5. Combine like terms, set the equation equal to 0. I have a squared minus a minus 3. And guess what? It doesn't factor. So you have to use quadratic formula. Get a decimal value when you use quadratic formula. In this particular problem, I'm going to look it up. In this particular problem, it's going to be negative 1.3 and 2.3. When you put that in the quadratic formula, you'll get that. So we have 2.3 out here. We have negative 1.3 here. Is it going to be open circle or closed circle? Closed circle because of the original problem. And then we test the intervals. Okay, to see what works. I think I'm just going to test 0 real quick because that's easy. Here I have the first, I'm going to have 0 over 0 minus 1 minus 2 over 0 plus 1 is less than 5 over 0 minus 1. Is that a true statement? Is negative 2 less than negative 5? No. 0 doesn't work. So you're going to get this situation here. This doesn't work. I think this will. This won't. This will. But this won't. Okay? That's the easiest way to solve that. If you want to read the book, look at the example. They have you setting this original inequality equal to 0. And you'll have something on the left less than 0. So you want to look at all the places where it's below the x-axis. And it's a nightmare trying to find all these values, but maybe you're a little bit better with that than I am. Algebraically, I think this is a good way to go. Okay? Your homework is going to be on page 526. Problems 28 through 36 even. If you already did those, You don't have to do them again. And then on page 517 and 518, 10 through 52 even, and 55 through 57 all. And we will have an opportunity to work on these in class tomorrow and get your questions answered on these last two sections. Okay? So, all right, and that's your lesson.